Hey there! I'm gonna go ahead and do some math problems. I'm not gonna be able to fit all of the math problems in this time segment because I'm expecting a class in a couple minutes. But I'll go ahead and make another video for you. Alright? So let's go ahead and get started on the first problem here. It says that we want to tell whether the function is a exponential growth or decay function and find the constant percentage rate of growth or decay. So first of all, I see that this is a 1.018, which tells us since this is greater than 1, this is a growth function. To find the actual percentage growth, we would subtract this number from 1. And another way of looking at this is 1 plus 0.018 in parentheses here. And so the actual percentage comes from this decimal here, 0.018. And if we were to convert this decimal into a percent, move the decimal over 2 spots, we would end up with 1.8% growth. And that's it. Let's move on to the next problem. We're going to find the exact solution for this algebraically. We want to find out what this x value is equal to. The first thing I'm going to do is I'm going to simplify the problem by dividing both sides by a 3. And that gives us 4 to the x over 2 power is then equal to whatever 96 divided by 3. 32. So from here we need to figure out what the x value is. So what I'm going to do is I'm going to rewrite both sides so they have the same base. 4 is 2 to the second, and 32 can be represented as 2 to the 5th power. And so if I multiply my exponents here, I have just 2 to the x now. So 2 to the x equals 2 to the 5th, which means that x is simply equal to 5. So that means that our unknown value here is just equal to 5. Alright, so let's move on to the next problem. We're going to go ahead and solve this one as well. We're going to find the exact solution algebraically once again. So I'm going to start this one off by rewriting this log function, this log equation, as an exponential equation. So base 4 to the negative 1 power then is equal to x minus 5. And when we have a negative exponent, cross the line, change the sign there. So 4 to the negative 1 power is 1/4. And then we add 5 to both sides, and we end up with 1 over 4 plus 5 is equal to x. Well, I want to combine these and get a common denominator, and so I'm going to multiply this 5 by 4 over 4, which gives me a 20 over 4, which is just equal to a fancy 5. And so we have a 20 over 4 plus 1 over 4, which gives us a 21 over 4 for our x value. Alright, let's go ahead and move on to the next problem. We want to solve for x. So first thing I'm going to do is simplify my problem a bit by dividing both sides by 80. And we end up with e to the 0.045 x power then is equal to 3. And I need to figure out what x is equal to. So I need to somehow get this x all by itself. And the way that we're going to achieve that is by taking the log of both sides. Specifically, I'm taking the ln because I'm dealing with an e. And the reason why we're doing this is because I can use the power rule to pull this exponent in front of the ln. So now we have 0.045x times the ln of e is equal to the ln of 3. Well, what's the ln of e? The ln of e, that's like saying log base e of e. Well, e to the first power is equal to e. So that means the ln of e, this guy here, is equal to a 1. So that means that we can just look at the problem like this now, right? So we're going to solve for x by dividing both sides by 0.045, and that gives us x is equal to the ln of 3 divided by 0.045. And this answer is perfectly acceptable for me. If you want to convert it to decimal, you can. Really, the only reason I see converting into a decimal using a calculator is to check your answer. So remember that you can plug in that x value back into the original x to make sure that you are indeed correct. So let's move on to number 17. Once again, we're going to solve this, figure out the exact solution. And so I'm going to start off by isolating the log. So I'm going to subtract 3 to both sides. And then I'm left with a negative log. And it's a base 10 because the base is not shown. It is a base 10. So we have negative log of x plus 2 is equal to a 2. Now we multiply both sides by a negative to get a negative 2 over there on the right. And then let's go ahead and use our definition of log to write 10 to the negative 2 power is equal to x plus 2. So now we have 1 over 100, which represents 10 to the negative 2 power, and we subtract 2 to both sides to isolate the x value. And now I'm going to multiply by 100 over 100 to get a common denominator. And so we have 1 minus 200 over 100 is equal to x. And then that means that we have negative 199 over 100 is equal to x. And voila, our solution. Now I see I have 1 minute left. You're probably going to hear the bell ring in a second. So let's go ahead and end this, and I'll pick back up and finish the rest in a little bit. Let's hear a word from our sponsor now.